The Sporland division of Parker Hannifin proudly sponsors the Advanced Refrigeration Podcast. There are a lot of questions surrounding the transition to A2L refrigerants and a lot of talking heads disseminating nebulous answers. But when your technician is face-to-face with the first A2L transition project, where do you turn for real-world answers about this specific job? Parker Sporland's Virtual Engineer is an innovative online design tool to size and select the correct components for climate control and refrigeration applications. Get your A2L system flow and component selection answers in 3 simple steps. Enter your application details, size, and select products, then download your project files. It's that easy. Try it at absolutely no cost. Visit sporland.com and navigate to the Resource Center. Parker Sporland, leading the charge.
Screw all of you.
What is it, like a sandwich? Yeah, screw all of you. It's an adventure.
Good afternoon, everybody. Welcome to Advanced Refrigeration Podcast. You're their host, Brett Wetzel and Kevin Compass. How you doing, my friend?
Oh, just finishing a rack swap out that I couldn't do last week.
What did you end up doing last week?
I flew to Texas to go put out a fire. And and then I had a Cascade CO2 adventure.
I heard.
I realized how much more I hate Cascade CO2. Hate it. It's awful.
Well, if things are checked properly, it should go smooth, right?
It still sucks, but still awful.
So, no, I know. I know you did.
The whole floodback thing still irritates me. Where like it just starts high heading.
So we talked about like when we have EPRs in CO2 where like you typically would go not across the valve, but usually from the suction side and go directly to the liquid line. But the pictures that you sent me where it was basically going across the expansion valve and going to the liquid line.
Which made it increasingly a pain in the ass to figure out if the case was piped backwards or if the valve was backwards or if the EEV was just stuck. So it was like, it could have been the symptoms of all three that are slightly different was doing all three things. So it was like, oh, this is a treat.
Yeah, so in that one that you sent me the picture, where essentially you were going around the expansion valve, but the problem is if that check valve was in backwards, essentially you could have flow and screw whatever the expansion valve was doing. It's just going to dump perpetual copious amounts of liquid directly into the coil, bypassing the orifice and being like, yeah, you're just going to flood out your suction to holy hell.
And the dumb check valves around all the ball valves, I hate it. I hate it. Because again, couldn't shut off the suction line because it's just blowing right through. And then if the case was piped backwards on top of it, okay. We need to go the Carnot route and just put stickers for safety. And then if you have a case pipe backwards and a check valve pipe backwards, there ain't no shutting it off at all. The moral of the story is, while you're doing this and piping it, check every check valve with a mirror. And then we had some of them where they were wrong, but somebody peeled the sticker off and flipped it around the other way. So you look at the sticker real quick, you're like, oh, the flow's right. And I'm like, wait a minute, those dimples are on the wrong side. Son of a bitch.
What kind of manufacturer check valves were those? I couldn't tell by the picture.
They were mega checks.
Were they?
mega checks.
Okay.
Yeah. Yeah, most of them were mega checks.
Yeah.
So that was the absolute treat. Yeah, that was not a fun startup. And then dealing with the flood back, it was flooding back so bad that it was actually causing high head pressure issues because we were getting liquid to the plates, and you can't push liquid through those plate and braze plate heat exchangers, so it causes it to high head. And then the EMS company had the braze plate heat exchangers locked down and percent, and that's not enough. And it was screaming, and they wouldn't answer the phone. So it was a trip. It was a trip. There were some good guys. I've seen some stuff I've never seen before in my career.
You got to finally meet the Scotsman, though.
Oh, he was a real treat, real great time, real fun time at dinner too.
I went out to dinner with you guys. Oh my God, he's gonna kill me. And I told I love your accent talking to the Scotsman. And he's yeah. And I said, hey, if you give him a couple of drinks, you're really gonna like it because he almost sounds inaudible, where he's very Scottish and you could barely understand him. And then the Scotsman goes, waitress, yeah, you might get lucky. And she turned bright red. I would laugh.
Yeah, it was a good time. It was a good time, but yeah, I worked a shit ton and stayed there all weekend working. So I don't know, it's done now. Minus the drains.
And here's the magnet check. So this is the dimples that he's talking about. So if you don't have a sticker on there, or you're trying to use a magnet to try to see where the arrow is, there should be like 4 or 5 dimples on this thing. So wherever the dimples are, that's basically where the flow is allotted to go. So it's an easy way.
I was just hit it with a mirror.
Yeah, and there's 4 or 5 all the way around, so you can blatantly see what it looks like and be like, oh, that's the way the check valve is. We were doing I did a class out in almost full-blown West Texas, out by Sulphur Springs this week, and we were talking about the importance of making sure with CO2 you have the same liquid line and suction line sizes, and a lot of those cases are made on a Monday, or a lot of cases are made on Friday. Yeah, so you check that and make sure all the check valves are in the proper 100%. Direction.
Yeah, 100%. Like checking after them to get everybody on their first or second CO2 store. There's always mixed up lines, which it's usually not that big of a deal. It's usually swappable, but the problem is when these check valves really threw a wrench in everything, because it was a pain to diagnose, trying to go through and figure everything out because it was flooding back so bad. Normally you're like, oh, I found the case, and it's looking at it, the Super E got marginally better. Oh, I found the case, it's got to be this one. Then it's like, oh, another one. It ended up being like 11 cases
that were swapped around.
So they were either line swapped. I think it was 2 line swapped, and then the check valves were swapping the rest. It was awful. It was not good. The OEM definitely dropped the ball with that one. I'm not going to say which OEM.
Thank you. Because then I don't have to say that I hate you. Stop it.
Got to throw one in there for you.
I hate you. Legitimately. Right now. Yeah. So, because one of the kids wants to learn how to do startup, I figure we do startup on Cascade.
Okay, yeah. So this was actually my first Cascade startup, because we have real CO2 out by me. The CO2 light. Yeah, we have Gatorade out here.
So what are the kids said so old? We get train. We were talking about transcritical. And then midway through today or yesterday, I threw in a little bit about liquid pumpography because they wanted to know some stuff about that. Is that like the Kool-Aid one or the Powerade one? I love everyone else.
No, liquid pump. That'd be like the 98. Liquid pumpography is like that 98-cent Kool-Aid ones they got at the dollar store, where you got to mix it yourself. But no, like we have the real flavor of CO2 up here. I get it. Like there's a place for everything. For with CO2, and yeah, Cascade may be this, but I'm not a big fan. It's got a lot more faults than transcritical. But going forward, so this is my first Cascade startup, and not a big deal. I've done Cascade racks before, so with HFCs and HFOs, so we're going through everything, just checking everything. And one thing that did get missed, because I was told everything was done, is the manufacturer high pressure switches were set way too low. From the factory, they were set way too low, and then it was getting in the operating range of the chillers for the Cascades, making sure that like all that stuff is set and ready to go. And the primary refrigerant side is good to go, meaning charged up, as much gas as you got in there. And unfortunately, this is a 513A rack, which I'm not a big fan of, and it was 10 degrees in Texas, which also Texas is not a fan of.
It wasn't 10 degrees.
It was 10 degrees.
It was 20. It felt like
it was 10 degrees when I
was not.
It was 10 degrees when I got there. It was too.
That's right.
You were from your house.
It's calling your ass out because you're like, yeah, I work in a t-shirt and maybe a sweatshirt in 10 degrees.
I was in a sweatshirt.
Like, why is it so cold?
I was in a sweatshirt. Everybody else was in bibs and coveralls. I was in a sweatshirt because I went to Dallas, and I figured it's going to be like 50 degrees. And I'm like, sweet, it's going to be warm in Texas, and I'm escaping Chicago climate where it was 0 all week. But yeah, regardless, so it was a bit of a challenge getting this thing going, just because it was so cold outside. So making sure the primary refrigerant's got enough refrigerant side's got enough gas in it, and it's ready to go. Compressors are bumped. This, unfortunately, did not have any 513A load in the store. The only load was the actual CO2 side. So charging this becomes an issue because you have no load to charge it.
Yeah.
Besides the chillers themselves.
Yeah. So we talked about this before. We have two different types of Cascade, right? We have a Cascade, straight up Cascade, which is what you had. And then we have a Cascade hybrid, which essentially just has not only the heat exchangers for a load, but also medium temp cases. I guess the proper way to probably charge that thing is probably when you're also gassing up the CO2, where you're increasing the pressure of the vessel and then trying to get somewhat of a load on there to bring that pressure down in that vessel.
So I shoved everything in with a recovery machine. I took the old Appian recovery machine, and it took it. It didn't like it, but like it was pumping straight liquid into the receiver of the 513A side. It was so cold, all the gas was on the roof, so like it wasn't going in. So I charged the entire 513A side and I got it up to 50% receiver. Just shoving it in with the recovery machine, which worked out pretty good because we had enough gas in it to start. And then I was able to start charging the CO2 side. Once we got the pressure up, I just started dumping tanks in the liquid side and valved off the liquid lines like I normally would in a transcritical rack.
Mm-hmm.
And valved off the liquid line, and I just kept dumping it in until I got to, 55% CO2 receiver. And then I let it rip. A little too fast at first.
Was she jumping around?
The Appian machine? Yeah, there was a tank of gas on top of it holding it down.
Didn't work.
It was too cold to stand up there and just put your foot on there. So tank of gas works pretty good. But so I think if I would have started this thing up the way I did and there wasn't all those backwards check valves, it would have went really good. But we had some issues, and I don't understand why there's a 380-pound relief on this thing. So I ended up blowing a 380-pound relief on the suck.
Oh, okay. On the okay. Probably because typically, you could technically go to 430.
Yeah.
450.
Yeah. I think the relief is way too low, but like the check valves being backwards shoved a bunch of pressure in there real quick, and the compressors didn't like it. And they went off on high head. and the person on the roof didn't notice it.
Oh no. So I'm going to show a picture real quick.
Good.
Go on. So this is what he's talking about. So because you have EPRs, if you were to try to if you try to check valve around the EPR, it's not going to work because you're going to close, you're going to cause a higher pressure, and then it's inevitably just going to go right around. In this instance, they put a check in parallel with the expansion valve. So if this does shut down, the pressure at least can go through the distributor and right over yonder and up and around, because there's no itty bitty teeny tiny orifice basically restricting that refrigerant. Whatever the size of the liquid line essentially would just, hey, we're just going to dump copious amounts of liquid directly in here and then do a little bit of what someone laughed at us for and saying, and then flooding out. So you don't know if the lines are backwards or if you have this little check valve in backwards.
Yeah, because usually if the lines are piped backwards, what you'll usually see generally is your suction pressure will be at the vessel pressure at the case. Well, it's usually a pretty much dead giveaway that you're piped backwards. But in this case, it was doing it with check valves backwards because it was shoving so much liquid in there and it was increasing the pressure, and compressors no leak. But it was also causing head pressure issues because we couldn't push through the plates because it was basically condensing instantly. So that was a huge issue. So besides that, if we wouldn't have had that, it would have fired right up and just took off.
Was there any communication issues?
Oh, yeah, there's comm issues, but you can only imagine a comm network pulled in Texas.
That's horrible. Absolutely horrible.
It wasn't a single marked wire in the store.
Did they follow the prints though?
Oh God, no.
What?
Did anybody ever? Those are suggestions. That's how every electrician takes it.
The as-built are made as we're building it.
Yeah. That's basically an electrician's thoughts on that. But no, other than that, like, it started up pretty smooth. Once you get the HFO or HFC side rolling, it started up pretty smooth.
Yeah.
Once we got the chillers opened up some more, we were able to pull the CO2 down more. That was a big thing. They had them labeled, or they had them shut down to like 65%. You couldn't go any more open. So they were just pretty much pegged at 65% all the time.
Did they say why? Because that was a certain store that has a secondary.
No, they have no idea.
Cool.
Yeah, no idea. There's no reasoning behind it. Just, I think they should have been able to go to 100.
Yeah, the only reason why I think that you would have to do that is if the heat exchangers were smaller than what the expansion valves were in there.
Yeah,
right?
No, it definitely, even at a full load, like where everything was like calmed down, it's 55%ish, or 50. It's like 55, 60%ish.
So I have to ask, once you got the thing charged up, because I told you about one of the hybrid ones I was dealing with, where all the expansion valves would essentially shut down downstairs and then literally cut the load by an astronomical amount. Was there enough flow where you actually had a straight, solid sight glass rolling over to the expansion valves? Since the heat exchangers were the only load on there for the medium?
It got lazy at times. It definitely got lazy at times until I got some more mass flow going. And once the valves opened up some more, it 60 area when they were below 65%, or 65%, they were lazy. It was lazy liquid. As soon as it got to 85%, it took off.
So does that one have split for the heat exchangers?
I think it did, yes.
Was it being utilized?
I don't remember.
Okay.
No, because we had all the load in the world. I mean, it was...
Yeah, fair enough.
We were doing startup on a Thursday night at 9 p.m.
It was rather cold, though.
It was rather cold, but I mean, it was loaded up. The superheater wasn't doing anything, obviously, because it didn't have anything to de-superheat because it was not superheated.
It was subcooled going to the discharge line.
Well, there was a lot of subcooling going on in the discharge line. It's just,
so if you had to do it,
you don't want to run it like that. But like at the end of the day, you don't have a choice in order to find everything.
if the pre-checks were done, I hit that home.
Yeah, but some of those check valves are so buried that I don't even know how some of them you can't even get to.
Well, as far as like the lines being swapped, right?
The lines,
that's something that definitely could have been avoided.
Nah, I don't know. That happens. A couple of those lines were wrapped around each other in the back walls. So if you looked at them, the left-hand line was.
Go ahead.
The left-hand line was. You don't pipe cases. You don't understand what's going on.
But shut the hell up. No, what I'm saying is,
when was the last time you piped a case?
I don't want to talk about it. But no, you have. But like the case, I know where the lines are. And I know that every single case that you have to, that where those lines are going to be, if you're bolting the cases together, you're going to have to take out the shells and you're going to have to take out the back wall. So take 2 extra damn seconds.
The carpenters are doing that, not the pipers.
See, that's a union thing. The guys that usually set the cases are usually the ones, the foremans down here in Texas.
I don't want the guy that's setting cases, piping cases. That sounds like a real catastrophe right there, because that's carpenter work. It doesn't take brains to bolt cases together. It takes brains to lay out piping and pipe things. Maybe that's why the entire North has less problems. Because we have carpenters piping cases.
Nothing is ever good enough for you. Ever.
I just say shit happens. I have never been on a CO2 startup where there's not at least 1 or 2 cases piped backwards. It happens. The manufacturers need to do a better job of tagging them. And in this case, they were actually wrapped around each other. So if you looked at the left line and you were to shake it, it was shaking the right line because it was wrapped around the lines in the back wall. They were spiraled around each other.
Okay, I'm still going to stand by what I said. If you're having to bolt the cases together anyway, okay, you can check the lines before you pipe them in, because that extra 5 minutes is going to save you 3 to 4 hours of time to then pump down the whole system and then have to rip the back walls back out and check those pipes after to make sure that.
Who's ripping the back walls out? Nobody's ripping the back walls out.
Not when you have to put the cases together. They get bolted in the back. Or did you forget because you're not a carpenter?
I'm not ripping the back walls out. I'm not a carpenter. I use my brain. I use it impact and butyl.
Except when welding.
I'm saying is we're not switching them, and we're not pulling the back walls out to re-switch them. We're just pumping them down and swapping them inside the case.
I understand that, but I'm saying the initial find, so you don't have to pump them down and re-swap them in the middle of your startup.
I'm not worried about that. I'm worried about the 78 backwards check valves the manufacturer put in. That was way worse. Because usually a backwards pipe case doesn't do anything. A backwards pipe case does not flow back. A backwards pipe case doesn't have any flow. But
except for this instance because of the check valve. Because the extra check.
Correct.
Gotcha.
A backwards pipe case usually is whatever. It's just, that case isn't warm, or that case is warm and the suction pressure is 500 pounds. It's piped backwards. So that's, who cares? Just, we'll deal with it in a minute. But in this instance, though, a backwards pipe case turned into a liquid cannon. Because even if the check valve was the right direction, it turned it into a liquid cannon.
Liquid cannon bad.
Yeah, liquid cannon bad. Liquid cannon full flow. But yeah, I think the check valves are the dumbest thing ever. They should not be there. They should be somewhere else. And there should be 1 EPR for the entire lineup, not 1 EPR per case.
Today's episode is sponsored by the RefraShield RDP Series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP series differential pressure monitors, including the new transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales@westermeyerin.com. That's WESTERMEYERIN.com.
That I would agree.
And it should be field piped. Yeah, it should be field piped, not manufacturer piped. And it should be 1 EPR per case. We don't need an EPR per line per system. That's a waste of money.
How do you do dual temp then?
Yeah, but some of those cases were 3 or 4 cases. It was 3 A, B, C. Like, what do you mean how you do dual temp? You're not doing case A at dual temp, case B, and they're all open to each other. There's no case dividers between each one.
Oh, I was talking about like if you had coffin cases.
Yeah, coffin cases are different, but these are glass doors.
Oh, you just said case in general. You did not specify.
When was the last time you piped a coffin case?
It's the fucking shit. You're such a jerk.
Got them off his hands.
That's funny. That's funny. So you didn't bring this up, and I'm actually surprised. When we were up in AHR, I said something about my office hands to one of the guys that we met, and he looks at your hands. He's a field guy. I'm like, son of a bitch.
No, he said technician hands. He goes, oh, technician hands.
He son of a bitch. Jeez, so much.
But yeah, no, other than that, or Cascade CO2, it is cake. It literally is. It's not that hard. There's not much startup to it. It as long as you go through your checks and check everything. Obviously, we went through all the sensors, all the valves, all the EPRs, went through them one by one and sprayed them with duster and made sure that they're all in the right spot and made sure that they're all good. And then you need to go back and make sure that nothing's laying on defrost heaters, because this is like a huge thing with all the OEMs. A lot of these cables are getting put in pretty long, so defrost heaters are burning stuff. And make sure anything the electricians wired, they didn't leave 78 feet of wire in the ends of the panels of the evaporators.
Yeah, I don't know why they do that. They could not leave 400 feet of wire.
It's just move it. If they need to move it, like, where are you going to move it to? It's in the coil. And then everything went great. We had everything down. We started the other 513A rack, and then I just heard the reliefs going off like a choo train. I'm like, what's going on? This thing has been running for 12, 13 hours. It's been beautiful. The electrician turned the power up to the UPS and blew the charge. He put in the dead front cover on the panel, and he turned off like 7 breakers. It was like, oh, that was Friday night, about 8 o'clock. So then we recharge it again. So the moral of the story is have lots of CO2 on site.
No, that's not the moral. All this stuff is to make sure you do checks. Oh,
well, we did the checks, but it's hard to do checks when Shorty, the electrician, turns off the breaker for the rack and then drives out of the parking lot at 85 miles an hour.
Couldn't figure out what breaker it was.
Oh, I found it after like 30 minutes of looking.
Does that unit have?
It wasn't
that
an
unit
EDC.
have? Did that unit have a auxiliary condensing unit?
No.
Really?
Which would have saved all of it. No auxiliary condensing unit.
That's
what it was cold enough. I could have probably ran the superheater if it had power.
Probably. No, I've heard of people actually doing that for both the liquid pump overfeed and the Cascade, where they charge
anything
auxiliary condensing unit.
But you could do that. You could. I've done 2 Costco startups where we shoved all the gas in there with the auxiliary condensing unit running. Like I pre-charged the flash tank with the happy on recovery machine. It pumps CO2 pretty good.
I know. Fully aware.
It makes a lot of noises, but it doesn't. It makes it go way faster.
Oh, I get it. I don't know what else. I don't know what else you would do. You know what I mean? Like it would be a lot better. We're having the hybrid, right? Like the hybrid rack where you can actually have the medium temp rolling, like already taking care of some cases downstairs.
100%. It would have been so much easier. It would have been way easier to have a hybrid rack.
Yeah, because then at least you can have some medium temp cases rolling, and then you could be selective on how much CO2 you're putting in, and at least have one compressor, whether even if it's short cycling, or if you're trying to slow down or speed up the variable speed, just to let it ramp up and ramp down to control the suction pressure, and just have it just stack all that refrigerant into the vessel.
I am also 100% convinced that these Cascade racks need EPRs on the chillers, or they run like shit.
This one didn't have them.
Nope. This one had digital unloading with EVs, which is not the greatest because you got no buffer there, and your suction pressure is constantly changing, and it's constantly all over the place. It's not changing like a ton. It's keeping it within 2 to 4 pounds, but that 2 to 4 pounds is enough to throw off the PID loop for those EVs.
100%.
So that's just something to be aware of. And I'd rather see a VFD on something like that if you're going to do that, or I would rather see some like big 2 5/8 just to give you like a pound or two of buffer. So that way you're not hitting that digital compressor swing and it's causing that issue.
Then you have a more steady suction on your evaporators, essentially your heat exchangers. So your expansion valves can actually have a steady suction. So the algorithm doesn't get all wonky.
Yeah, no, you're just fighting yourself. You're never going to get a good control without EPRs. And that's the whole thing with CO2's missing as a whole. And I was pretty stoked to see all the EPRs and all the cases for the CO2 side. I'm like, oh, this is great. I'm glad more manufacturers are starting to push the EPRs, and it's going to give you so much better control. It did. Not a big fan of pulse valves, but they did a way better job of maintaining case superheat and case temperature. The return temps coming back on the CO2 side looked a lot better than a lot of the other Cascades I've seen. I was in the 25, 30 degree range instead of being like a 45, 50 degree return gas temp.
Not just that, but it makes having a dual temp case a lot easier because now you can actually raise your saturated suction instead of having a, 40 or 50 degree TD. And now the coil is like 5 times what it's supposed to be. And the expansion valve is just trying to chug away, trying to feed that thing as much as humanly possible. So, it was bad. It's bad control in general. But other than that, it takes off pretty easy. I'm just not a big fan of 513A. The list is big. You're not a fan of 513. You're not a fan of electricians. You're not a fan of Cascade refrigeration.
Nobody's a fan of electricians. Electricians don't even like electricians. Any person that's afraid of a broom.
It's awful. Absolutely awful.
No,
I feel like we barely covered the startup of this thing. We just complained about how well your startup went.
No, all in all, it ended up being a good time. We got a lot done. I was very disappointed I didn't get Texas barbecue because I worked late every night. And I didn't get Texas barbecue besides Buc-ee's, which is like the classy gas station chain.
At least you got to hang out with Greggy.
I got to hang out with Greggy, and I got to insult him for hours. And then you made it worse.
What do you mean I made it worse? I didn't do anything.
Because you just insulted him for hours also.
I did not.
And you enjoyed every bit of it.
I did not. Blasphemy. Just said, all I said was that your brother had to come and bail you out.
It's the Cascade CO2 is got to be one of the easier racks to start up. As long as you do your checks and everything's good. I would think the other style where you have some HFC or HFO in the store would be a million times easier. I'm pretty sure that's how HEB does it, right? They got
Yes.
513 in the store for medium temp.
Yeah, all their hybrids. And then, because you said there was a separate 513 rack was just for the medium temp, which blew my freaking mind because
it was a big rack.
I understand that, but it really didn't make any sense to me. I know how that vintage of store is set up, and I'm like, the medium temp is right next to the low temp, so it's not like it's adding like a copious amount of piping.
It's insane the line sizes for 513. When I look at it was like 3 1/8 suction going down some parts. I'm like, Jesus.
What was the load on the whole rack though?
But it's such a low mass flow refrigerant. If you would have made that 448, it would have been like a 2 1/8 line.
Oh, as far as the BTUs per pound.
So that's how 134 was always. Like the lines are massive. So same with 12. That's where you end up these giant lines. But no, I didn't get the whole second 513A rack. But I will say this: that rack was huge for what it was. I don't know if it's a load thing because I know if you're over a certain amount of BTUs on one rack, you end up getting close to like where you may have to have an on-site engineer. That's the only thing. But it was the E3 store. They went flawless with that side of it. That was cake. And I will say the E3 is so much better with the like all the case controllers like than the E2 was. It integrates so much better. So much easier to set up all the logging.
So I'm looking up the 513 information versus the 448. So 513A HFO blend on the liquid enthalpy at 0 degrees, it's 17 BTUs per pound. The liquid enthalpy for 448A is essentially 28 BTUs per pound. The vapor enthalpy is the same. It's both 95. And then the latent heat of vaporization for 513 is 78, and 448 it's about 67. So I'm assuming it would go off of the liquid enthalpy, right? How much energy that has. So I guess the liquid lines would have to be bigger, but I don't know how much the suction lines would technically have to be bigger. And I really want to know.
They're bigger, way bigger.
I would want to know like what the reefer schedule said, like how much that load would be.
I purposely don't get reefer schedules because I know you always ask for them and it drives me insane. I purposely don't get them anymore. Because the first thing out of your mouth is, you got the reefer schedule in the PNID diagram? No.
Because you're explaining shit to me. And you're like, goes over here and then through this little thingamajigger and then over to here. And then I'm like, I don't know what you're talking about. Visualization.
I draw it.
You need to be able to visualize it.
Like a 12-year-old so that you could see it. That's the PNID. I want to make you work for it.
Don't ever ask me for my opinion ever again. Ever.
You love it. You love it. But yeah, it's the 513A side was huge. That's actually a pretty good sized charge in the other rack too. It was like 1,600 pounds.
Really?
It was close to that, probably like 13 to 1,600 pounds. I lost count. We had to use 25-pound cylinders, so because nobody had 100-pounders. So
no one at 513 nowhere.
No, which you would think about it. There's not a lot of racks using 5 in Texas. It is for HEB, but if you ask for that much 513 up here, nobody's got 513 in any racks up here.
Yeah, but the Heb stores have. It's almost at every single freaking Heb store.
Yeah, I bet. So they probably have around there. They probably have a ton of 513A. But
that's what I mean. That's why I was surprised that no one had it.
513A in the winter times, no good. No good operator.
Did someone leave the cans outside?
Oh yeah.
Really?
And the CO2 sucks at that too, though. So.
Yeah, but it also doesn't. Oh yeah, true.
No, like it's trust me, when it's 0 degrees outside, they store the CO2 outside in cages. It ain't going in.
Yeah, true.
And I don't know if you ever tried to warm up CO2 bottles. It doesn't really work.
I hate you.
It's no different. It's no different than any other refrigerant. How much 448 and 404 have you jammed in the suction of a racket? Don't tell me you haven't. See the lip moving.
440, 449 are not as miscible.
Thousands of pounds.
Oil has CO2.
I've seen pictures of you having 100-pound cylinders hooked at the suction headers.
What are you talking about? There is no such thing.
Yeah.
After this, we're going to find out who has those pictures, so they don't exist.
Every mechanic in every supermarket is hooking that 100-pound cylinder right to that 3/8 tap on a suction header and letting them eat.
Fine, but not with CO2 because it just wants to carry that damn. We're
You
like,
gotta-
okay, you can get.
You gotta throttle it. You gotta throttle a little bit. What are you gonna do? You gonna throw the food away, or you gonna tell them, "Oh, I gotta warm these tanks up for the next 4 hours because that's about how long it takes." Or you gonna throw away all the food, or are you gonna throttle it slow? Let's be realistic here.
I am being realistic.
You're gonna throttle it slow.
No, I'd do something. All right, enough of that. I'm done. I'm done with you today. Jesus.
What would Brett do?
If the tank was already low, like if the tank pressure was really low, right? I would put it in the liquid line right before the expansion valve, let the expansion valve just meter through. So at least you have the coil boiling off that refrigerant. That's exactly what I would do.
Same but different.
No, it's
What if you don't have taps in the straight? What if you don't have taps in the Schrader line on the liquid lines? 80% of these stores demand.
shut off the loop.
Got you there.
Shut off the loop. Shut off the loop. Shut off the loop. And then put in the
Where you
ball
gonna put
valve.
it?
Put in the ball valve before the.
There's
Before.
no taps. You know that, right? 80% of these retailers are demanding no taps in the liquid lines.
Case by case basis. That's all I'm gonna say.
Case by case basis. Just throttle it slow.
I'm gonna agree to disagree.
Throttle it slow. Throttle it. The ice cream agrees.
The pizza rolls agree.
Nobody eats pizza rolls.
They do.
I'm an adult. I can get normal pizza
Jesus.
or cookies.
All right. On that, we're gonna end. I'll talk to you guys later.
Yeah.
Bye.